Assalamualaikum to Dr. Idris and to all audience. For in this video, I, Pangeran Muhammad Lutful Hadi, will be answering question 15 in problem 3.3 that has been assigned by Dr. Idris himself in this test video assignment. So, without further ado, let's get started. Basically, this problem statement tells us that it is a heat exchanger type of statement. So how can we tell? Firstly, it already mentioned the word heat exchanger right here, and the second thing, it provided us two states, which is the first one is air and the second one is the combustion gases. So after analyzing this problem statement, we will identify what the question asks. So basically here it asks us to find the rate of heat transfer of the air and not these combustion gases, don't get mistaken easily, and the outlet temperature of the air. And right here it also provided us uh, the answer for this question, which is for the rate of heat transfer, it is equal to 67.93 kilowatt, and the outlet temperature is equal to 120 degrees Celsius. So before we answering this question, we should list all the data given in the question. In this slide, I decided to divide the data into each state to avoid random mistake in calculation later. Right here is an example of a schematic diagram that I include with to help me understand better in terms of solving this question. So basically, here is the pathway for of heat exchanger for the air, and number one as its inlet area with temperature of 20 degree Celsius, and number two as its outlet area. Also here it shows that the volume flow rate for air is equal to 0.6 meter cube per second as it travels along the pathway of heat exchanger. Same goes for the gas state, but only it is in reversible direction, where the gas entered from number 3 and out at number 4. Previously in data in air state, volume flow rate is given instead of mass flow rate. So we need to find the mass flow rate for air state to help us to find the rate transfer of heat for air and its output temperature. We know that the product of mass flow rate and specific volume is equal to the volume flow rate. We also knew that based on the given data that volume flow rate is equal to 0.6 meter cube per second. So all that's left is to find the specific volume by using the ideal gas equation of state, because our substance is air. So after obtaining the specific volume, we now can calculate the mass. So after obtaining the specific volume, which is equal to 0.885 meter cube per kilogram, we can now calculate the mass flow rate for air by using the equation here, back here, and we obtain the mass flow rate is equal to 0.678 kilogram per second. So after we obtain the mass flow rate of air, we can now find its outlet temperature by using energy balance equation. The energy balance equation, and simplified it into like this, and rearrange it into like this, which is mass flow rate of air times with its difference in enthalpy of air equal to mass flow rate of gas, multiply with the difference in enthalpy of gas. So we also knew that enthalpy is equal to this specific heat multiplied with the temperature. So we use this equation here to replace the difference in enthalpy for air. After fill in all the data given in the equation, we obtain that the temperature, the outlet temperature of air is equal to the 119.74 degrees Celsius, which is close to the answer provided in the question, which is 120 degrees Celsius, if you rounded it off to the whole number. So after obtaining both mass flow rate of air and its outlet temperature, we can now find the rate of heat transfer of air. So by using energy balance equation, we simplified it into like this, which is Q in plus mass flow rate of air time multiplied with the enthalpy, the inlet enthalpy of air equal to the mass flow rate of air multiplied with outlet enthalpy of air, and we rearrange it into like this, and we fill in all the value here. I decided to keep this answer of mine previously, which is 119.74 instead of 120 degrees Celsius provided in the question. And now we can obtain the rate heat of transfer of air, which is equal to 67.96 kilowatt. Basically, those previous calculations and equations is one of the method to solve for heat exchanger question that is involved in determining the rate of heat transfer and the outlet temperature. So if my method is incorrect to you, feel free to correct it in the comment section down below. That's all from me, and thank you.